Okay guys, so today we will talk about chapter 4 part 2. So it's the continuation of our first part where we discussed the definition of networking. We discussed the types of network, and then we also discussed different transmission media, the types of the transmission media, and their the difference between prepaid, postpaid, and we also discussed some network devices as well. So today we're gonna continue our lecture and we'll talk about some network devices, specifically routers, switches, and we will also discuss the role of IP addresses. Then we will talk about wireless local area network, and we'll discuss two main terminologies of wireless local area network. One is the SSID. We'll discuss the role of SSID and how we can avoid the piggybackers to get into our network. Other than that, we will also discuss the application of networking, and specifically virtual reality versus augmented reality. So let's start with the router first. So as discussed in the last video, we discussed router is basically it's a network device which connects two or more networks. For example, you can connect your home network with ISP, or you can connect one network with another network through a router. What else router can provide? Router provides hardware firewall, which protects the internal network from malware or outsiders, and it also incorporates a switch. And if you remember, switch connects the devices within the network. Nowadays we use a specific kind of router which is known as dual band router, as name suggests, dual band router. So a router that operates over two distinct frequencies is called dual band router. So what are those frequencies? Frequency is 2.4 gigahertz, which is the most commonly used frequency range, and secondly 5 gigahertz. So these nowadays the routers that we use, they operate at 2.4 gigahertz and 5 gigahertz. At 2.4 gigahertz, so 2.4 gigahertz is very populated. It's kind of overcrowded nowadays, and that's why we have added this 5 gigahertz, because at 2.4 gigahertz there are many other devices they actually work like at 2.4 gigahertz there is a lot of interference from microwave ovens and car alarms. So that's why 5 gigahertz is, of course, it's better as compared to 2.4 gigahertz. You will get better signal at 5 gigahertz. Next is the IP address. I believe most of you guys heard about IP address. IP stand for Internet Protocol, and IP address is basically name of the computer over internet. So IP address is basically name of the computer over internet. So whenever you connect your device with internet, ISP assign you IP address. So ISP assigns the IP address to all connected computers. It's not basically all the computers, but ISP assign one IP address to your home access point or Wi-Fi router, and then like for example, you have one access point, so you will be assigned one IP address, let's say 1.1.1, okay? And then what will happen, it will further do the subnetting within your internal devices, and then whenever you will access anything publicly, they will see this IP address which is assigned to your access point. For example, if you stop using internet, your IP address will be assigned to somebody who is requesting for it. So once you disconnect your device with internet ISP assigns your IP address to someone who is requesting for. Unless you have a static IP address, which most of us, we don't have that. Next is the network troubleshooting. It's kind of self troubleshooting. For example, if your internet is not working, network is not working, so how you can do your own troubleshooting. The first step is, if the network is not working, NW network is not working, then firstly check the status of indicator lights. So you just have to check the indicator light. So the second step is, you need to check to make sure the cables are not damaged and properly plugged in. Thirdly, poor signal can be an indicator that hardware, or you can say your access point of the router is outdated, is maybe old or improper positioned. So you need to change the position as well if you want. Next is the last step. And sometime the firmware updates, it can occur, and that can cause the network outage. And if something like that happens, for example, if network, because of the firmware update, network outage occurs, so you just have to reboot your device. So just reboot device, like you need to restart your computer. That's it. I mean, your router, in fact. Next is the switch. As we already talked about switch a lot. Switch is basically a device which connects devices within the network. So switch, as you know, it is incorporated within the router, and it connects devices within local area network. And how it distinguishes the devices. Switch, for example, this is your router. So as I mentioned, switch is basically inside the router. It distinguishes the devices based on their MAC addresses. Okay, MAC address is basically you can say their physical address, which will never get changed. Like your IP address can change, but your physical address will never ever change. So switch, it distinguishes between various devices within network by their MAC addresses. Next is the some typical terminologies for the wireless local area network, and starting with the SSID, service set identifier. What is basically service set identifier? We'll talk about it, and what's the role of service set identifier, in fact. So SSID stands for service set identifier. Service set identifier, and it's basically the name of your Wi-Fi name. For example, at GGC, the SSID is GGC wireless, GGC guest. These are the SSIDs. And router transmit SSID after every few seconds, so they can be found. Very important thing. For example, if all your legitimate devices, once they get connected with your access point or with the local area network, then transmitting of SSID becomes unnecessary because your devices, they remember the SSID. So what I'm trying to say is, after all devices have connected to SSID, then transmitting of SSID becomes unnecessary because it just let the devices know that I exist here. That's basically where I'm located. Then if you talk about the Wi-Fi was basically, the concept of Wi-Fi was introduced back in 1997, but at that time, like people, they didn't adapt that technology because of the security reasons. Then in 1998, first security algorithm was introduced named WEP. It's called Wired Equivalent Privacy. So the wired equivalent privacy, it was the first encryption algorithm that was used with the WLAN, or you can say Wi-Fi. This algorithm, we still use this algorithm. It's pretty much a nice algorithm, but without a security key. There's no concept of security key or the secured access of the access points. But this algorithm was reported to be vulnerable in 2003. So it was reported to be vulnerable in 2003. Then in 2004, another algorithm which was intended to replace WEP, it was named as WPA, Wi-Fi Protected Access. So WPA, they introduced the concept of a security key, like you need to know the Wi-Fi password in order to get connected. But encryption scheme or encryption algorithm of WPA was extremely poor, that the life of WPA was just 6 months. So it was quickly replaced with, within the same year, it was quickly replaced with WPA2. And we still use WPA2 in our algorithms. And the best technique is you should use WPA2, which will provide you excellent encryption security, plus the disable SSID. So you can actually block the piggybackers from getting access to your network. Firewall, as we already talked about, it actually if you really wanna protect your networks from internal networks from malware, we need to use firewall. Other than that, firewall also separates two networks. If you want to separate two networks, you can place a firewall in between. Let's say this is one network and this is another network. You want to separate these two networks, you can actually place a firewall in between. You can actually separate two networks or even two computers on the same networks. On the same network. Other than that, with the firewall, what else you can do? You can, regularly, like, it protects the internal networks, internal devices, or you can say networks, from malware. And usually firewall, as we talked about, it comes as a built-in within the routers. Then in order to make a network, there are many type of models that we can use. We can use client server model, we can use peer-to-peer model. That's what we use in the internet. So first of all, what is a client? In a client server model, client is basically a computer which requests for resources to other computers on the network. That is called a client. So client is basically, in server-based models, individual individual's computer or device or devices are called clients. Or you can say, or as I mentioned earlier, a computer that requests for resources. Resources could be web page, it could be images, services from another computer on a network. On network is called client. Now, these client and server-based models, these are more popular as compared to peer-to-peer model in local area network because they offer more security. Just imagine, in peer-to-peer network, everybody has, like, say, in peer-to-peer network, let's say something like that. All the computers, they got the same powers. Like, there is no powerful computer. Let's say if you connect your device with the network, you will have the same privilege, same powers. So of course it doesn't offer that good security. While in server based model, there is a server. If a client want to do something, if a client even want to access internet, it has to request to the server, and then server can actually get this request completed or denies the request. So server based models are more popular than peer-to-peer models because they offer more security. Secondly, when client requests to access a resource, or you can say internet, this request is controlled by server, the powerful machine. Okay, all these clients, these are also connected with, or they can interact with each other through server. So individual computer, or you can say device, computers or devices connected to network also interact through centralized server. So server basically make them communicate with each other. The last thing for today, it's the application of networking, and that's the virtual reality. You have seen many gadgets which are coming up now, which are of course in the market nowadays. We use virtual reality stuff like for treating the treat the phobias like fear of heights, to get the to train the pilots for flight simulator and stuff like that. That's basically the virtual reality. It's kind of a 3D environment where the person can actually interact with other people, and it seems like something. The things are happening in the real world. So virtual reality, the definition is it's the 3D computer generated environment. It's completely 3D and completely computerized environment which can be explored and interacted by a person. So a person can actually interact with other persons. So while a person is submerged in the virtual world, they can interact with other characters of the virtual world. Other characters, they can manipulate things, and they can also perform many tasks as well. So by using these virtual reality, it's not only for entertainment, you can also use it to train your pilots, for example, flight simulators, and treat the patients. Like phobias and all that stuff. A very close related thing is augmented reality. Augmented reality is not basically the complete virtual environment, but it's the integration of digital information within the user's real world environment. In fact, that's basically what the augmented reality is. So augmented reality is basically the integration of digital information with users environment in real time. So you might have seen I don't know whether you have used Waze or some other GPS like Scout, I guess, or something like that, where you will see the real roads, and you will see the digital information over the roads. That's basically what the augmented reality is. There are many challenges with augmented realities, like hardware design of hardware that can have the processing power required to handle the data. Sometimes it's very hard to manage the input, like, because what we can see infinite things, but we cannot record all those things on our digital devices. These are some challenges, in fact. So one of the challenges, larger amount of visual input and output. Other than these challenges, we do have some technical challenges in designing the gadgets. One of the technical challenges, basically latency, delay, like how much time it will take to capture the image and then integrating the digital information by going back to network and find the details about it. Registration errors, like there could be some errors, and the last is occlusions. For example, the blockage. For example, for example, you take a picture to find the details about the nearby restaurant. There are many apps, the augmented reality based apps, where you just take the picture and it will show you these are the restaurants and that's the rating of those restaurants. Sometimes it might happen a restaurant is basically its views blocking behind, it's basically located behind another building. So that's called occlusions. So this is all about chapter number 4. We'll discuss all that stuff in our class as well.